Welcome back, dear children. Now we will move to our second chapter, motion in one dimension. Okay, chapter 2, motion in one dimension. This is actually a very important chapter because in this chapter we are going to learn about the basic terms related to motion. Okay, the basic terms related to motion will be there in this chapter. So it's a very simple chapter. At the same time, it's very important. Okay, so shall we start? Okay, so what are physical quantities? In the first chapter, we have already learned about physical quantities and measurements, isn't it? Now, do you remember what are physical quantities? Quantities that can be measured, isn't it? Measurable quantities are known as physical quantities. Now, these physical quantities can be actually divided into two. They are scalar quantities and vector quantities. Okay. So, the quantities which we can measure can be divided into two. Quantities which we can measure are called physical quantities, and those physical quantities can be divided into two, scalar quantities and vector quantities. Okay. So now we will check what are scalar and vector quantities. Now, if I am telling that the length of this chalk is 7 centimeter. Okay. If I am telling it as the length of this chalk is 7 centimeter, that entire thing is complete, isn't it? So this is easily what you can easily understand that, and no way of some other doubt. I don't want to mention something more in order to understand that the length of this chalk is 7 centimeter. Okay, so in 7 centimeter, what all things I have said? If I am saying that the length of this chalk is 7 centimeter, I have said about 7 and centimeter, isn't it? And what is that 7? 7 means actually it is the, what is the name given for the numerical value? It is the magnitude, isn't it? Already we learned it. A physical quantity will be represented by its magnitude and unit. So, if I am speaking about length, its length is 7 centimeter, means 7 is the magnitude or the numerical value and centimeter is the unit. So, if a measurement is clear with its numerical value or magnitude and unit, you can call it as a scalar quantity. Okay. So, what are scalar quantities? The quantities which have only or which can be represented using its magnitude and unit. If we can represent a quantity using its magnitude and unit, we will call it as a scalar quantity. For example, I told you in the case of length, isn't it? Then again, mass. What about mass? If I am telling that the mass of this chalk is 0.12 milligram or 0.25 gram. Okay, let it be 0.25 gram. Let the mass of this chalk is 0.25 gram. So it is complete in that, isn't it? No need to give more explanations about that. So such quantities which can be clearly expressed with its magnitude and unit can be called as scalar quantities. Another example, the time of a usual period in class period is 40 minutes. So in the school we have 40 minutes periods, isn't it? Each period is of 40 minutes. So if I say that the time of one period, class period is 40 minutes, it is complete in that. So I don't want to give more explanations for that. Okay, so that is also an example. Time is also an example for a scalar quantity. And these scalar quantities are represented by their English letters. So if it is mass, I can give it as M. Then for length usually we'll give L. For time we'll be giving T. Okay. So what are scalar quantities? Quantities which can be represented by the magnitude and unit. Now look at another example. I'm going to apply, now the chalk is on my hand, isn't it? I am going to apply a force of 10 Newton on this chalk. Okay. I am going to apply a force of 10 Newton on this chalk. So if I said like that, is that sentence complete? Or did you understand the entire thing related to that? I am going to apply a force of 10 Newton on this chalk. Okay. Again I applied a force of 10 Newton. Now also I applied a force of 10 Newton. I think it is visible for you. First I applied a force of 10 Newton. Then I applied a force of 20 Newton. Now a force of 5 Newton. So I have applied force on the body. But if I simply say that I have applied a force of 5 Newton or 10 Newton, is it correct? Or is it complete? No. In the case of force, if I just said that I have applied a force of 10 Newton, there can be a question, that is, in which direction did I apply the force, isn't it? So in the first case, I have applied force in this direction. After that, I applied force in the backward direction, then sideways. So in the case of force, if I simply say as 10 Newton, that is incomplete. Here I should say in which direction I have applied force. Okay. So such quantities which are represented using its magnitude, unit and direction can be called as vector quantities. Okay. So what are vector quantities? The quantities which can be expressed using its magnitude, unit and direction. If you are considering scalar quantities, you have to say only about the magnitude as well as unit. No need for the direction. In the case of mass, time, etc., we don't want to consider the direction. But when you are speaking about vector quantities, you have to say about the direction. Okay. So when you are considering force, displacement, in all these cases, we have to specify the direction. Okay. So what are the examples for vector quantities? Force, displacement, weight, etc. Now, the next thing about its representation. A vector quantity is generally represented like this. That is, after writing the letter, we will keep a arrowhead there. Above that, a line with the arrowhead above a vector quantity. So if you see like this, that represents that it is a vector quantity. Or if it is written in bold letters, okay, if it is written in bold letters, then also it means that it is a vector quantity. In the case of scalar quantity, normal addition, subtraction, multiplication, etc. can be done. But in the case of vector quantities, we have a different type of numerical operations. Okay, actually this vectors is a topic which comes in maths. You have a separate branch in maths related to the topic vectors. Okay, it comes only in higher secondary levels. For the time being, you just know what is the difference between scalar and vector quantities. About the vector addition, multiplication, etc., you will learn in maths in higher classes. Okay, so is it clear? We have discussed just about two things. Physical quantity means which can be measured. Quantities which can be measured. It can be classified into two, scalar and vector. Scalar means which can be quantities which can be represented using their magnitude and unit. Quantities which require magnitude, unit and direction to get represented can be considered as vector quantities. Example for scalar quantities: length, mass, time, etc. For vector, force, displacement, velocity, many quantities are there. So when it comes, I will tell you. Okay. Since we didn't learn about velocity and all, I am not mentioning it now. Then when you are considering scalar quantity, it can be represented directly using the letter, English letter. But if it is a vector quantity, either write in bold letters or you can give a line with an arrowhead. Normal mathematical operations are possible in the case of scalar quantities, but in the case of vector quantities, we have separate numerical operations. Clear? Next, we will move to the terms rest and motion. Actually, all the bodies in the universe are in a state of motion, isn't it? But again, why are we using the term rest? We are considering rest and motion. We are using the terms rest and motion with respect to the immediate surroundings. When can you say that a body is at rest? If the position of the body does not change with its immediate surroundings, you will say that the body is in the state of rest. Now, when I am considering this room, what about the position of this board? Or what about if I am standing like this? What about my state now? With respect to this room, I am in the state of rest, isn't it? But when we are considering the whole earth, I am in the state of motion. Why? Because earth is rotating and revolving, isn't it? So when earth is moving, together with that, I am also moving. So a body can be either in the state of rest or in the state of motion, and we will describe state of motion or rest with respect to the immediate surroundings. Okay. So what all things you have to remember? A body is said to be at rest if its position does not change with the immediate surroundings. And a body is said to be in motion if its position changes with the immediate surrounding. So now if I am walking, okay, then I am in the state of motion with respect to this room as well as with respect to earth. But when I am standing still, with respect to this room, I am at rest. But with respect to earth, I am in the state of motion. So is it clear? Please by heart the definitions for rest and motion. A body is said to be in the state of rest if its position does not change with immediate surroundings, and a body is said to be in the state of motion if its position changes with the immediate surroundings. Clear? So we have learned about one part of our heading. Motion, isn't it? Motion in one dimension is the name of the chapter, and we have learned about motion. Now, next is one dimension. So what do you mean by one-dimensional motion? If a body moves in a straight line, okay? If a body moves in a straight line, then you can say that it is one-dimensional or 1D motion. Or there is one more name, it can be also known as linear motion or rectilinear motion, okay? So what is one-dimensional motion? If a body moves in a straight line, then you can call it as one-dimensional motion or linear motion or rectilinear motion. For example, a body moving along a straight line path, a car moving on a straight road, an object which falls from a height, then it comes straight, isn't it? So if a body is moving in a straight line, we will call it as one-dimensional motion. And if a body is moving in a plane, so here when you are considering a plane, this can be considered as a plane, isn't it? So when a body is moving in a plane, then you will call it as two-dimensional motion, and that is a ball rolling on a ground. If it is moving just straight, then that is a straight line motion, and in between if we are applying force and if the ball turns, if it is on a plane, then you can call it as two-dimensional motion. And if a body moves in space, you will call it as three-dimensional motion, okay? So 1D, 2D and 3D. If a body moves in a straight line, that is one-dimensional motion. If it is in a plane, then two-dimensional motion, and if it is in space, then it is three-dimensional motion. And in this chapter, we are going to learn only about one-dimensional motion. Okay, so you should know what it is. One-dimensional means straight line. Two-dimensional means in two directions. If a body is moving on a plane, ഒരു സർഫസിലൂടെ ആണെന്നുണ്ടെങ്കിൽ ഒന്നില്ലെങ്കിൽ ഇങ്ങോട്ട് പോകാം അല്ലെങ്കിൽ ഇങ്ങോട്ട്, in two directions it can move. This is opposite of this. Okay, so two directions anengil, that is two-dimensional motion. And if a body is moving in space, let us consider a flight moving here, so there will be three directions for it. That is three-dimensional motion. So we are going to discuss just about one-dimensional motion. Okay, now how can we represent one-dimensional motion? In maths, you have learned about the Cartesian coordinate system, isn't it? X, Y axis. When you are drawing the graph, you will be drawing X axis, Y axis. So, just if one axis is considered, that will be our one-dimensional motion. So, for one-dimensional motion from the Cartesian coordinate system, we will be considering just one direction, okay, or one axis. This will be for one-dimensional motion. If it is two-dimensional motion, you will consider, what is the name given for this axis? X-axis. This is Y-axis, isn't it? So for two-dimensional motion, we will be considering Y-axis also. And actually we have one more, that is Z-axis. So this will be considered in the case of three-dimensional motion. Okay. So what you have to remember? For one-dimensional motion, we will be considering only one axis. Two-dimensional, two. And for three-dimensional motion, we will be considering the three different axes, X, Y and Z. So is it clear till this? Okay. So what all things we discussed? We have discussed about physical quantities, scalar and vector quantities, then rest and motion, one-dimensional motion. If a body moves in a straight line, we will call it as one-dimensional linear or rectilinear motion. And in this case, we will consider only one axis. Okay. And we have to study only about one-dimensional motion in this chapter. Clear? Okay. So with this, we'll stop. And I'm going to give you few homework questions. And one more thing, no need of lecture notes from this. I need just the question answers. Okay. You can take page number 35 in your textbook. Page number 35, exercise 2A. Question number 1, 3, 4 and 5. Just 4 questions I have given as homework. So 4 questions from this and from the previous video. You can do the numericals. That will be the homework for you. Okay. So exercise 2A, question number 1, 3, 4 and 5. These are the homework questions. So please study by heart the definitions from this chapter. Actually, you have to by heart many definitions. So study the definitions, do the numericals and be ready for the Google Meet. Okay. So thank you, children.